All right, let's talk about something that's really shaking up how we build with large language models. It's a framework called DSPy, and it's built on a super powerful but simple idea. We should be programming our AI, not just, endlessly prompting it.
So let's get real for a second. If you've ever tried building anything with an LLM, you know the pain, right? It's this endless, frustrating dance of tweaking words, running it again, tweaking some more, basically just crossing your fingers and hoping for the best. Sound familiar?
And you end up with these absolute monsters. I mean, look at this thing. It's this giant, complicated paragraph of instructions. It's kind of a masterpiece of weird engineering, I guess, but it's also a total house of cards. Super brittle, a nightmare to debug, and just forget about trying to maintain it.
And that right there is the core problem, the real pain of prompting. This whole method of wrangling text, of trying to be a prompt whisperer, it's just not a stable or scalable way to build serious software. What happens when you change your model or your data? The whole thing can just fall apart.
So what's the answer then? Well, this is where DSP steps in. It introduces a totally new way of thinking, a new paradigm that says, let's stop focusing on these messy, fragile text prompts and start focusing on what we know works, structured modular code. And the difference is, it's night and day. Just look at this. On the left, you've got the old way, that long, clunky string that's micromanaging the model, telling it exactly how to think. But on the right, that's the DSPy way. It's one clean line of code that just declares what you want. It's a huge shift from telling it how to do something to just telling it what to do. The creators of DSPy have this perfect analogy for it. They say it's like the jump from writing an assembly to writing in C, or from doing manual pointer arithmetic to just writing a simple SQL query. It's a massive leap in abstraction. You get to stop worrying about the messy, low-level details and actually focus on the logic of what you're trying to build.
Okay, so how does DSPy actually pull this off? Well, it all boils down to two key ideas, the core building blocks of the whole system, modules and signatures. First, let's talk about modules. The easiest way to think about a module is like a reusable component or even a function in your AI program. Instead of a big messy prompt, it's a piece of code that encapsulates a reasoning strategy. So you might have a chain of thought module for step-by-step thinking, or a React module when you need to use tools. Now every module needs to know what it's supposed to do, and that's where signatures come in. A signature is just a super simple, human-readable string that tells the module its job. What are the inputs and what are the outputs? It's that classic separation of concerns. The signature defines what to do, and the module figures out how to do it. And that's what makes the system so flexible and so powerful. So putting it all together is actually incredibly simple. It's a three-step dance. Step 1, you define your signature. What goes in, what comes out. Step 2, you pick a module that knows how to do that kind of task. And step 3, you just run it. You call it just like any other piece of code. It's that simple, it's clean, and you can piece these things together to build really complex systems. And the payoff for taking this programming-first approach is huge. Your AI systems become way more reliable because their logic is in actual code, not some finicky string of text. They become so much easier to maintain because you can update one module without worrying about breaking some weird dependency in a giant prompt. And they become portable. You can swap out GPT-4 for Llama 3, and you don't have to rewrite your entire application from the ground up. Okay, but here's where things get really wild. This is where DSP goes from being a really good idea to being an absolute game changer. It's not just about writing cleaner code, it's about writing code that can literally improve itself. Let's talk about the real magic here, self-improving programs. And this magic happens through something called an optimizer. Honestly, the best way to think of it is as a compiler for your AI program. You write your high-level DSPy code, you give it a few examples of what good looks like, and you hit compile. The optimizer then goes to work, automatically tuning everything under the hood. It figures out the best prompts, the best examples. It does all that tedious manual prompt engineering for you. So how does a powerful optimizer like MIPROBE 2 actually work? Well, it's pretty systematic. First, it runs your program and collects examples of where it did a good job. It learns from its own successes. Then, it starts proposing dozens of new, better instructions based on what it learned. And finally, it kicks off this intelligent search, mixing and matching all these new ideas to find the absolute best performing version of your program. And the results? They are just stunning. Seriously, take a look at this.
They had a React agent. That's a program that uses tools to answer complex questions, and out of the box, it had an accuracy of just 24% on a tough data set. But then, they ran it through the MyPro V2 optimizer, and its accuracy more than doubled to 51%. That's an incredible leap.
And it's not a one-off. Here's another amazing example. A classification program using the smaller, cheaper GPT-4o model started at 66% accuracy. After DSPy's optimizer worked its magic, that number shot up to a staggering 87%. I mean, think about that. These aren't just tiny improvements. These are huge performance gains that the system finds all on its own. You're basically getting way better results from a cheaper model, essentially for free.
Now, progress like this doesn't happen in a vacuum. This isn't just the work of one small team. DSPy has grown into an entire ecosystem for building better AI, and it's all being fueled by this incredible, fast-growing open-source community.
You know, the research kicked off at Stanford NLP back in 2022. The first version, called DSP, came out later that year. And then DSPy, as we know it, launched to the public in late 2023. And now, it's got this thriving community with over 250 open-source contributors all pushing it forward.
And you can really see the power of that community in action. People aren't just using DSP, they're actively building on top of it. We're seeing brand new optimizers pop up, totally new program architectures, and all sorts of cool applications, all of it created and shared by the community. It's this amazing, virtuous cycle of innovation.
So at the end of the day, DSPy represents a massive shift in how we think about building with AI. It's moving us out of this fragile, low-level world of just fiddling with prompts and into the structured, high-level world of actual programming. And if prompts really are the assembly language of this new era, it leaves you with a really exciting question, doesn't it? What are we all going to build now that we have the C and the SQL of AI?